guys, so for today's vlog, I'm going to teach you how to use the Solver and Goal Seeker feature of Microsoft Excel through these three problems.
So our first problem is optimization by Solver. A shipping company has a capacity to move 100 tons of cargo per day by air. The company charges $250 per tons for air freight. Besides the weight constraint, the company can only move 50,000 feet cube of cargo per day because of limited volume of aircraft storage compartments. The following amounts of cargo are available for shipping each day. So we have here the list of cargo. We have three cargoes, 1, 2, and 3, and their weights na makakarry, so 30, 40, and 50, and their volume, which is 500, 50, 800, and 400. So we're asked to find the maximum profit for the shipping company. So first things first, we need to set variables for cargo 1 and 2 for easy solving or manipulation. So we have here, so we let A, B, and C represents cargo 1 and 2 and 3 respectively. So and for our objective, we're asked to find the maximum or maximize profit for the shipping company and then our objective function in here is based on the problem. The company charges $250 per ton. So in here, our objective function in here is also $250 times per cargo. So we let A plus B plus C be equal to the maximum profit. So this is our function in here. This is our objective function. So next, we need to establish our constraints. So we set here for A, B, and C. Okay, copy this A, B, and C. So our first constraint, so C1 underscore is weight. So our first constraint, based on the problem, it says there that a shipping company has the capacity to move 100 tons of cargo per day by air. So we need to do total. So by that, we have an idea that the maximum tons of that the shipping company can carry per day is 100. So we have here, Then we have here 1 times the cargo A, and 1 times the cargo B, then 1 times the cargo C must be less than or equal to 100. Less than to equal to 100. So that is our first constraint. And then our second constraint, or C2, is about the volume. So volume. For the volume, it says there that the company can only move 50,000 feet squared of cargo per day because of limited volume of aircraft storage compartment. So we need to input here the volumes. For A, we have 550, 800 for cargo 2, and then for cargo 3 is 400. And this must be less than or equal to 50,000. So it must be less than or equal to 50,000. And then for our third constraint is for the cargo one. for letter it's represented by A. It says there that the cargo one is a maximum weight of 30 tons. So in here for A we have here 1, and then for the other B or the cargo 2 and cargo 3 represented by C it must be 0, and then for constraint 3 or for the A it must be less than or equal to 30. It says here in here. And then for the constraint, for the fourth constraint is for the cargo 2 or represented by capital B. And for the from the table, its maximum weight that can be carry is 40. So for A we have 0, and then for 1, and then for 0 for C, and then this for cargo B it must be less than or equal to 40. And then for constraint 5, C5 is for cargo 3 or represented by letter C. And then this must be 0, 0, and this is 1 times C for cargo. So for our constraint C5, and this is for cargo 3. For cargo 3, its maximum weight that can be carried is 50 tons. So this must be less than or equal to 50 tons. So after establishing our constraint, we need to establish our decision variable. So for our decision variable, we give initial value for A, B, C is equal to 5. So we set here for A we have 5, and then B is 5, and then C is 5. And in here for total, for every equation of every constraint, we solve this using the initial value of 5. So for in here, for total, for the constraint 1, its total value is equal to the A times initial value of 5, then plus the cargo 2 times its initial value of 5, then plus cargo 3 times initial value of 5, then equals. And then for the volume, same thing goes. So from 550 times its initial value 5, then plus cargo 2, which is 800 times its initial value of 5, then plus cargo 3, it's 400 times 5 equals 8,750. And then for constraint 3, we fit this to A times the initial value of A. Then for same goes for cargo 2 and 3 equals cargo B times the initial value of 5, and then equals, and then for C, which is represented by cargo 3, equals C times the initial value of C, which is 5, and equals. So by our objective, the objective 3, 2, 1, go. So 3, 2, 1, go. So by objective, the maximum profit is equal to 250 times each cargo is equal to the maximum profit. Cover A, B, and C is equal to maximum profit. So we need to multiply each cargo by 250, and 250 So by objective function or the equation for our objective, we have here um, 250 times the cargo 3, 2, 1, go. So by objective, in order to compute for the maximum profit, we have 3, 2, 1, go. So by objective, in order to compute for the maximum profit, 250 times each cargo is equal to the maximum profit. So we have here A, B, C, which represents the cargo, and then our maximum profit. And then for our base in here, our objective function, we need to multiply each cargo by 250. So 250 and 250 in here. So by our objective function, we install in here for cargo A multiplied by in here, then plus this one in here times the initial value plus this one in here times the initial value of cargo C, which is 5, then equals. At this initial value of 5 for each cargo, for cargo 1, 2, and 3, our maximum profit is 3,750. And then in order to find the maximum profit, we can use the solver of the Microsoft Excel. So under the data tab, we can find here the solver at the upper right corner. So click this. In the set of objectives, we need to click the tab for our maximum profit. We need to click for the maximum profit. And then in here, we need to choose the max since we are asked to find the maximum profit. And then for the changing variables, we need to click for the decision variables. So these 3 in here. And then after that, in the constraint, we have here our constraint. So we need to add, for the cell reference, we highlight this for total. Then this should be less than or equal to this group of cell in here. So after that, we need to click OK, and then solve, then OK, then this is our maximum profit. So this is the maximum profit that a shipping company can gain. So the maximum profit of the shipping company is 24,218.749999 at a value of cargo 1 of 30, cargo 2 of 16.875, and for cargo 3 is 50. So our next problem is system of equation using the solver. So we have here 3 equations, and our goal in here is to find the roots of x, y, z using the solver function of the Excel. So this is our objective, find the roots of x, y, z. So after that, we need to establish our constraint. So our constraint is based on every equation. So for our constraint 1, we should base this to equation 1. So this equation in here, 2x plus 4y plus 5z minus 33 is equal to 0. So if we transpose this negative 33 in here to the other side, it will become 33. So our constraint in here is that this equation 1, this 2x plus 4y plus z should be equal to positive 33, where 2 times x plus 4 times y plus 5 times z should be equal to 33. And then for our constraint 2, same goes. Um, with by transposing this negative 70 in here, it will become positive 70, and this equation 2 in here should be equal to positive 70 if 6 times x plus 6 times y plus 7 times z should be equal to 70. For constraint 3, based on equation 3, by transposing this positive 71 in here, we have a negative 71. So by equation 3, 3 times x minus 6 times y plus 4 times z should be equal to negative 71. So this is our constraint for this problem. So after establishing our constraint, we need to establish our decision variable. So we set the values of x, y, z to 1. So we have initial value of 1 for x, y, and z. X, y, and z. So we set this for 1 and 1 and 1. So after inputting the values or the initial values for x, y, and z, for the total in here, we need to evaluate these three equations by the given initial value of 1. So in here, for equation 1, we put equal sign, then open parenthesis, then 2 times the initial value of x, which is 1, then plus 4 times the initial value of y, which is 1, then plus 5 times the initial value of z, which is 1. Then click enter. And then for the second equation, we do the same. So we put equal sign, then open parenthesis, then 6 times the initial value of x, which is 1, close parenthesis, then plus, then 6 times 1, or the initial value of y, which is 1, then plus 7 times the initial value of z, which is 1. Then click equal. And then for the third equation, we'll do the same thing again. So we put equal sign, then open parenthesis, then 3 times the initial value of x, which is 1, close parenthesis, then plus negative 6. Don't forget to put the parenthesis for any cell when performing equations to avoid miscalculation. So then times the initial value of y, then close parenthesis, then plus 4 times the initial value of z, which is 1. Then click equals. So after solving for the total for each constraint, we can now use the Excel solver. So under the data tab, click the solver. Then in here, for our objective, we can use the constraint 1 in here as our objective, then click max. And then our changing variable in here are these decision variables. This one. Then after that, we need to add subject to the constraint. So add, and then our cell reference in here is the total for each constraint in here. So we drag this one, and then this total in here should be equal to this cell in here. So then okay, then since this is a simple linear problem, then in here, this check in here, we can remove this because as we all know, roots can also be negative, so we can remove this one. Then click solve, then okay. So our roots are for x we have 6, for y we have 11.5, then for z we have negative 5. So So we can highlight this one, put some color to emphasize the values. Then that's it. So this is for the system of linear equations using the solver of the Microsoft Excel. So our third problem is root finding using the goal seek of the Microsoft Excel. So for our problem, find the specific volume of N-butane at 500 Kelvin and 18 atm using the Redlich-Kwong equation of state. So we have here the equations of our Redlich-Kwong equation of state, and then we have here formulas to find the parameters, the needed parameters to solve for the Redlich-Kwong equation. So we have here for the A, formula for B, we have here the values for the critical temperature and then the critical pressure, and then we have the formula to solve for the reduced temperature, and then we have here a formula to solve for the alpha, and then in here we have a value of our R constant, so 0.08206. So in here I already inputted the values or the needed values. So for our objective, we need to find the specific value of the N-butane using the Redlich-Kwong equation. So our equation of state is Redlich-Kwong. It's Redlich. And then this is the formula. So I already typed this formula for later referencing. And our system is N-butane. So based on the problem, here are the given values. For the temperature, we have 500 Kelvin. For the R constant, so I converted this one into centimeter cube para mag-agree yung mga units natin lahat. Then we have a 82.06 centimeter cube atm over grams mole Kelvin. And then for the pressure, we have 18 atm. For the critical temperature TC, we're given with 425.2 Kelvin. And then for the critical pressure, we're given with 37.5 atm. And so solving for the other parameters that are needed in order to solve for the specific volume of the N-butane, so we have here the reduced temperature. So based on the given, the formula to find the reduced temperature is just equal to the temperature, which is the 500, divided by the critical temperature, which is 425.2. Then click enter. So our reduced temperature is 1.175917.215. And then for the alpha, based on the given in here, the formula to solve for the alpha is 1 over the reduced temperature raised to 0.5. So perform the calculations, type equal, then type 1 divided by the reduced temperature raised to the power of 0.5. Click enter. So the value of our alpha is 0.922171351. The next, solving for A. So the formula for A based on the given. So the formula to find this one is this one. So I already inputted the formula. So we just need to copy this one, then put it in here, then put equal before the equation to perform calculation. So we just need to change the referencing in here. So for the value of R, we have here. Then for the critical temperature, we have here. And then for the critical pressure, we have here. And then for the ER, which is just equal to the alpha. Just equal to alpha. We just can change this to just equal to alpha. So the value of A is 12798105.79. And then solving for the value of B, so based on the given formula in here, this is how we solve for the value of B. So I already inputted this in here for the easy calculation. So we just need to copy this one, then paste it in here, then put equal sign to perform calculation. So just go and change the referencing. For R, we have here R constant. Then for the critical temperature, we have here for for 25.2, and then for the critical pressure of here 37.5 atm. Then click enter. So these are the values of A and B. So we just need to highlight this one. So after this, solving for V. So after that, going back to the objective of finding the specific volume. So solving for V, we have this equation in here for the Rayleigh-Kwong equation. But we cannot directly use this one because we are missing with the initial value of the volume. So in order to find the initial value of the volume, we can use the ideal gas equation, which is equal to PV, or the pressure times volume, is equal to the R constant times the temperature, T. So by manipulating this equation, we can solve for V. So V is equal to RT over P, which is the pressure. Computing for this, since we have already the value for R, the temperature, and the pressure. So do some calculations in here. So by referencing value of R constant 82.06 times the value of the temperature, which is 500, close parenthesis, then divided by the value of our pressure, which is 18 atm. Then click enter. So our initial value for this is 2279.444. So our initial value for the volume is 2279.444. And our F of V, which is represented by the Rayleigh-Kwong equation in here. We can copy this one. See? And then we can remove this equals 0 in here. Then we can solve for this value by inputting or changing the references, then doing some calculations in here. So we can put equal sign, then changing the references or referencing. So V times the pressure, which is 18, times the volume is 279.444, times the value of R, which is the 82.06, times the value of temperature, which is 500, times the volume, and then the value of A, this one, then the value of pressure again, then the value of B, which is yung nasa baba, ito, and then the value of R again, and then the value of temperature, which is 500, and the value of B, this one, then the value of A, and then the value of B, this one, then click enter. Since it is stated in the Rayleigh-Kwong equation that f of b should be equal to 0, but in here we have this is not equal to 0. So in order to make this equal to 0 and then to find the real specific value of the volume, we can use the goal-seek feature of our Microsoft Excel. So under the data, click the what if analysis, then click the goal-seek. And in here, we have this prompt in here in front. So our set cell is this one, then this one, then to value of 0, since it is stated in the Rayleigh-Kwong equation, it should be equal to 0. And then our changing cell is the cell of our volume, so in here. So the result of this goal-seek is our value of the specific volume. So then click OK. So the specific volume is equal to E is equal to this one. Control C. This is our value of a specific volume of the N-butane using the Redlich-Kwong equation of state. So that's it.
That's all for this video. Thanks and have a nice day.